What's the deal with Euler's number E? This is a very known constant in mathematics that occurs in several calculus topics, and in a logarithm, that's a natural logarithm, has the base E. And today we're going to try to see and remind us a little bit what were the first circumstances in which this constant occurred. It was Bernoulli around some centuries ago which first posed a following question. You have a bank that offers an interest of 100% yearly. And you have an investment that is $1. That's the initial investment. And the question is, what happens if this interest of 100% yearly is capitalized in different ways? And the first one is it's capitalized one time per year. And the calculation goes as following. You would have your S equal to 1, that's the $1 initially invested, plus 100% of 1, and this is 1 plus 1, well, that's 2. The second topic was what happens if this is capitalized 2 times per year. And now you have in the first half, you'd have 1 plus 1 over 2, that's the 50% times 1, and this is 1, just simply put 1 over 2. For the second half, you would have 1 plus 1 over 2 plus, now it's the 50% of your interest in 1 plus 1 over 2. And we will try to represent this a little bit more graphically so that we can see what's happening. You have 1 year, this is from 0 to 1 year, and you have your 100% capitalized here for your first case. For your second case, you would have from 0 to 1 year, and this is split in half. That's 6 months here, 6 months after, and you would get a 50% in this part and another 50% at the end. And these 50% are the 1 over 2 here and the other 1 over 2 here. And when you're making this calculation, now we can follow up on this calculation. You can factor 1 plus 1 over 2, 1 plus 1 over 2. This is 1. This is the 1 over 2 goes here. And this is 1 plus 1 over 2 to the second power. And this is 2.25. For the nth case, let's just take it n times per year. You would get directly try to deduce the result, and this is 1 plus 1 over n to the n power. Now, what would happen here is the following. You would get from 0 to 1 year, and you have this divided into several parts right here, and each is yielding at the end of the period 1 over n, 1 over n, and at the end is 1 over n. This is divided in a total of n periods, and when you add up all these times, n times, you obviously get 100%, so it's the same thing. And what was Bernoulli asking was, what happens if this n here is very, very large? That is, what happens if you are capitalizing the interest continuously, not a million times, not a billion times per year, but actually continuously. And that would mean, what is the value of limit when n goes to infinity of 1 plus 1 over n to the n power? And what he has observed is that this goes to constant value 2.71, something going to infinity. This subsequently proven that this is a irrational number. It's a transcendental number in a similar way to pi, and this is what was later on named as E. That's Euler's constant. So when you have an interest capitalized continuously over a year, you would get at the end of that year not 2.25, but $2.71. And that is the limit. You can do it a million, a billion times. You can do it a Googleplex times a year. You would not get a value which is larger than 2.71 approximately E number. That was it for today. This is a very interesting result. Stay put for our next topic on the E number, on what's the deal with Euler's number, when we would analyze some very special cases and why actually E is so special for mathematics, especially in the area of calculus, and why is the natural logarithm ln with base E called a natural logarithm. Until next time, don't forget to like, subscribe, and comment if you want to see any nice ideas. Have a good one.